Hello guys, welcome to another video of beginner Python. So in the previous session, we looked at lists. Um, so we discussed what a list is, we discussed the properties of a list, we did some slicing, like, you can access the elements using the index. Um, we did some slicing of the lists, a bunch of different things. We looked at the unique properties of a list. In this session, we're going to get into other data structures. Apart from lists, what are the other built-in data structures, right? So the first one that I'm going to talk about is something called a tuple. First, let me define a tuple, and then we'll get into what are the different properties of a tuple. So instead of using a square bracket, you use a parenthesis and you just do your thing. You just define the elements. So it can include duplicates. You can access the tuple using the indices, right? Absolutely fine. No issues at all. In that sense, it's pretty similar to a list. It can include heterogeneous types of data. Won't cause any issues with that. So very similar to a list. But the only, I would say, major difference is that a tuple is immutable. Now we know that a list is mutable, which means, you can just say, I want to change index 2 into 100. And it's going to do the job. No issues at all. Now index 2 is going to say 100. But if you try to do the same thing using a tuple, let's see if that's going to work. It's not going to work. Because a tuple is immutable. You cannot modify the elements within a tuple once you sort of define a tuple. So that's one of the major different property. Otherwise, I think it's very similar to a list. You can have very similar functions, right? So you can look at the length. You can do similar kinds of things with a tuple, right? Very, very similar to a list otherwise. And and since a tuple is immutable, you are not allowed to append new elements into the tuple, right? And you probably cannot, it doesn't allow you to add new elements into the tuple. But you can still do things like this where you combine two tuples and store it as a new tuple. This is still possible. Just that you cannot modify the same tuple, right? So T2 is still going to be a combination of these two. So that is mostly about tuples. Very similar to lists, but just immutable. Now, next important data type, or data structure rather, is called a set. So I think those of you who have, most of you would have studied sets in high school mathematics. So a set is nothing but a group of unique numbers, right? So you can have 10, 22, 4, 5, 9. This is a set. Now, what makes a set unique is the set can only have unique elements. So I mean, I can include 9 how many ever times I want, right? But when I actually print the set, it's going to have 9 only once. And also observe that it's in ascending order, something that I didn't have to specify. So it's sort of an ordered list of unique elements. Now, a set is mostly used for mathematical functions. So it's mostly used for mathematical operations. So let us say I have a set S1, which has a bunch of elements, and let's say I have set 2, which has another bunch of elements. So what I can do is I can perform set-based operations. So for example, I can do S1 dot union S2. So most of you might know what a union function does. Union just combines elements in both sets. That's what union means. So just how union is possible, intersection is also possible. So intersection helps you find get a set of common elements. So I can say S1 dot intersection S2. Oh, looks like there's a spelling mistake. There we go. So you can see out of these two sets, 2 and 5 are the only common elements. So you have 2 and 5. It's as simple as that. There is also something called a difference. So what a difference does is it'll tell you elements in one set but not in the other. So it's sort of like tells you the unique elements unique to one set. So I can say S1 dot difference S2 is going to tell me all the elements in S1 that are not in S2. So I have 3, 4, 6, 7. 3, 4, 6, 7 are not present in S2, as you can see. So that's the difference. Similarly, S2 dot difference S1 is vice versa. It'll tell me all the elements in S2 but not in S1. Right? So those are some important set-based functions. Mostly you use those kinds of set-based functions, and you always have your regular functions, like you can say length of S. That's totally fine, very much doable. You can do min of S, max of S. All these are totally acceptable. So there's no issues with that whatsoever. You can also do, and you can also of course add elements into a set as well. So you can say S dot add, and you can add a 23. So if you see S, you can see 23 is now added into it. You can also remove elements from a set. So these are all like common to those in a list. So you can say S dot remove 5. Now if you look at S, it's not gonna have 5 anymore. and see 5 is removed. So these are set-based functions usually used for when you want to compare two different sets, do unions or intersections or difference, things like that. But also you can do some other stuff like adding, removing, just how you would do with the list. So that's about a tuple and a set. Now there's one more super interesting data type or a data structure called a dictionary. Now this is one of my favorite data structures in Python. So what is a dictionary? Dictionary is nothing but a set of key value pairs. You can call it a set of key value pairs. So for example, I can say D is equal to, let's say I want to store the name of someone. This is my key, and I'm going to put a colon, and I'm going to define the value. So I'll say Jack. Then I can say, I can define another key. I can say city, and I can define another value. Like maybe I'll say Mumbai. Then I'll probably do age, and I'll say 34. So name, city, and age are called as keys, and the respective values are called values. The respective associations with the keys are called values. And we use a flower bracket to define dictionaries. So if I want to look at the values, I can say d.values. If I want to look at the keys, I can say d.keys. So I have my keys, I have my values. Now, I can also access the set of keys or values. So I can say d of name, and that'll give me my value. So if I pass a particular key, it'll give me the respective value, something similar to indexing, right? But here instead of index, you have a key. So you can think of key similar to an index, right? Now what happens, let's say if I do something like this. What if I have something like name Jack and I include name again, and I'll say name John. What happens then? It's not gonna give me an error, but it's gonna have the latest value for this particular key. So if it's Jack first and John, then it's gonna have John. So it'll include the latest values, right? So super useful, and not only can you just store a single data type, but you can also store a data structure. So you can say something like, you can do something like this. You can say names, and you can store a list of names like this. Jack, John, Tom, and you can maybe include their respective cities like this: Mumbai, Bangalore, and maybe Chennai. And you can store the respective ages within the list: 34, 45, 67. So very, very useful, right? So you can say D of names. That'll give you Jack, John, and Tim. And you can further access the list, just how you would do anything else, right? So if you want the information of, let us say, the second person, you can always say I is equal to 2 to define you want the information of a second person. So you can say the second name or the 2th name is Tom, and you can access Tom's city, and you can access Tom's age as well, like this, right? So you can store which index you want to work with, and you can get that. So I can say 1, look at that, it's going to give me John's information. If I say 0, it's going to give me Jack's information. So super useful, right? Now, a dictionary is once again mutable. A dictionary is mutable. So it means the key value pairs can always change. So I can say something like D of names, I want to change it to Jack, John, and Bob. Instead of Tom, I want it to be Bob. And that's totally fine. It's going to work. Now you can see you have Bob here and not Tom anymore. So that's what is super useful in a dictionary. You can always update a particular dictionary. And I can also, let's say I want to add another name into this. So I can just say D of names. D of names will give me their respective names, and I can just append another name like Tim, and that's totally fine. Now you can see Tim is also there within the names. So bunch of different functions are allowed, which makes dictionary super useful to store different types of information. Very, very useful from a data science, data analytics perspective. Now, let us say I want to convert 2 lists into a dictionary. So let's say one list represents keys and one represents values. So how exactly do I handle that kind of a scenario? So I can say, let's say L1 has my keys. So let's say L1 has name, city, and age. And L2 has the keys. Let's say it has Jack. Let's say it has New York City. Let's say age is 35, 34, whatever. Now, how do I combine these 2 lists into a dictionary? So first I'm going to zip these 2 together. So I'm going to say zip L1, comma L2. So it sort of means that L1 and L2 belong together. That's what zip does. That's what zip tells you. So whenever you want to sort of indicate that these 2 are sort of attached to each other, you're going to zip them up like this. And after that, you're going to say dict. So dict is the keyword for a dictionary on Python. And voila, there you have it. You have the names, city, and age. You have combined 2 separate lists into a nice dictionary. So one is the key, this is the value. So if you rather do L2 and L1, it will swap the keys and values. So that's how you can convert a list into a dictionary. Some other useful dictionary functions, you have something like d.items, which will sort of give you the key value pairs together. It'll return the entire dictionary key value pairs together, which is nice. Um, so yeah, these are the major dictionary-based functions. We look at more as we move into other topics like loops. But that's about the dictionary. Quickly, I want to cover a few things about the string as well. Now, a string, is it a primary data type like float, int, boolean, or is it a data structure? It's the data structure. What is it? Now, a string it acts like a hybrid. It's a hybrid. Though it can be considered a primary data type, it can also behave like a data structure. So it's a primary data type that behaves like a data structure because it can store a set of values, right? So what do I mean by that? I can store a bunch of values in a list like this, 1, 2, 3, 4. And there is no rule that disallows me from storing the same 1, 2, 3, 4 inside a string. I can still store 1, 2, 3, 4 inside a string. And can I slice it? Can I index it? Yes, I can index it. Totally fine. Can I slice it? Yes, I can slice it. Again, totally fine. Can I reverse it? Of course I can reverse it. Totally fine. So I can perform all the data structure kinds of operations or functions on the string as well. So you can consider the string to be a hybrid data type or a data structure, whatever you'd like to call it. There are a few useful string-based functions. There are many actually, but some of the main ones, there is a replace function which can help you replace a character or a set of characters. If I want to replace 1 in the string with, let's say, 5, that's totally fine. I can do it. Instead of 1, 2, 3, 4, it's 5, 2, 3, 4. So I can replace any character. I can just replace 1 with nothing. So you have 1 is gone. Right? So that's one of the useful functions of a string. So what happens if I have something like this? I have S1 is equal to hi, and I have S2 is equal to how. So I can do S1 plus S2. It's going to combine my strings very nicely. So very similar to lists or tuples. And you have some other useful functions like s.upper, or let me use this one. Let me call this as s is equal to s1 plus s2. So I can do s.upper, convert everything to uppercase. I can say s.lower, it'll bring everything to lowercase. If you want to capitalize the first letter only, you can say s.title. Only the first letter will be capitalized. First letter of each word, that is. So yeah, these are some important things of a string. So you can get the let's say index of a particular element. So if I want the index of h, it says there's a h in the 0th position, right? And what if I want the position of an h starting from index 2? It says 4 now. So I'm starting from 0, 1, 2. I'm starting from this position, and then I'm looking for the position of h, right? So if I want to say 5, it says starting from 5, there is no h that is found, right? But let's start from something else. Let's start from 2. Yes, starting from 2, that is the third element, H lies in the fourth index. So not only can you find the first occurrence, but you can find the occurrence starting from a particular place within the string as well. So yeah, these are some of the important things. There's also something called a strip in case I want to strip the string of particular characters, right? So in the ends, so for example, if I do this, you can see the question mark disappears from the end. So from the rightmost and the leftmost, it's gonna make sure this disappears. Not in the middle, only the rightmost or leftmost. So if I do H, the H disappears from the left. So that's about strip. I can also split a string into a list by choosing what I want to split on. So if I want to split on, let us say, H, it's going to split based on H. I want to split, let's say, based on exclamation mark. I can split based on the exclamation mark. So super useful. It's going to split a string into a bunch of lists. So that's about different string-based functions, super useful. So we'll stop this particular video. I'll give you some time for you to explore string-based functions. Of course, you won't actually get the hang of it unless you try it out yourselves. I'll see you guys in the next video.